Hello 88, it's John Stewart again. Connor's going to help me. We're going to show you what's going on with the vertical milling machine. It's a unique name. These machines are actually called after the manufacturer, kind of like Xerox machines. Vertical mills are always called Bridgeports because the Bridgeport company is the one that really made them popular. It's a good old line American company that's just about out of business now because the machines they made were so good that nobody ever buys a new one. The old ones never wear out. Okay, Connor, I suppose we want a pair of holes in this piece of aluminum. We want them 1/2 inch from the end, 2 holes 1 inch apart.
All right.
All right? How are we going to do that?
Well, first we're going to find the edge of our part so we can zero
Yep.
our head right there. So that way we can then go 1/2 inch that way to get our hole here.
Yep. I'm even going to say this was probably cut on a bandsaw, so the end is probably not
That's
square.
what it looks like to me as well.
All right? So the first thing we want to do is square off the end. All right? So why don't you reach for the 1/2 inch end mill and the tool holder over there.
Yeah, they're probably good.
Okay, 1/2 inch means it's 1/2 inch in diameter. This is an end mill, and that kind of looks like a drill bit, but it's not. An end mill is special because it'll cut on its side, not just on the end. So, we're going to put the end mill in.
All right.
We're going to hold the brake, loosen the drawbar on the top. God, who tightened this? Was it Paul Bunyan? And now we can unscrew it the rest of the way, and it should come out.
There we go.
Put it in the rack.
Yep. This guy.
And rotate it till it finds the key. Tighten the drawbar. Connor, what's going on? I thought I said that that's a 3/4 inch hex up there. How come the wrench says 19? 19 millimeter wrench.
Ah, it's
One of the
metric.
odd facts. 19 millimeters is so close to 3/4 that the tools are interchangeable. The other end is a 22 millimeter, which happens to be the right size to tighten up the clamp set we've got over there. That takes 7/8 imperial size. 22 millimeters, close enough that it'll work on those. We're ready to square off the end of the tubing. So start the machine, go to high speed. Let's go down to about 800 RPM.
All right.
Now, with this machine, to change the speed, the machine has to be running in order to change the speed. Remember that. You can't turn this handle if the machine isn't running. I'm going to cut her down. Now, it isn't quite down far enough, so bring the table up. Give me about 10 turns up.
So we're going to hit this dial right here. There we go.
All right. This dial, 1 revolution is 100 thousandths, so that's 1/10 of an inch. 10 turns gives us 1 inch. So we brought the table up by 1 inch. So travel to the left until you just make contact. You hear it? That's how you know. You can hear the sound. Okay? Travel away. Yep, hit away. Good. Keep going. It'll give me about 30 thousandths on the dial.
There we go.
Right? Now make your cut. All right. Stop the machine and let's show the people on the video what we're doing. Shay, come on around here and get in here real tight so we can see the end of the piece. Have we made good contact all the way around? You can see.
No. Actually.
You can see from the shiny spots where we've made contact and where we haven't. I can't exactly see it. I think we're a little shy. We're going to take off another 30 thousandths so that we've got a completely fresh machine surface on this end. So give me another 30 thousandths on this dial. Shay, come on in here and show everybody. This is calibrated in thousandths of an inch.
There we go.
On this handle and this one revolution is 200 thousandths. So if you want to travel an inch, you need 5 revolutions. Go again. Come on in here and watch right here. Watch right here as he makes the cut. Go ahead, Tom. Good. Let's stop the machine. Let's get a close-up of the end of the tubing. Now you can see you got a good clean cut all the way around. Now this end is perfectly square to that side. We want to start drilling holes. So the first thing we want to do is take the tool holder out and put the drill chuck back in. Go ahead, get started.
The 19 mil end.
Yeah.
Oh,
I'm
yeah.
going to bring the quill up so you can see the nut.
Oh, yeah.
Hold the brake harder. There we got it. Give it a couple of turns, then we whack it with the block to break it loose. So Connor, why am I using the lead block to tap the end of the drawbar?
Why are we using the lead block? Because A, we don't want to smack it in our hand. That would probably hurt.
Yeah.
But also, the lead block is going to give more force to take the chuck out of its holder right here. If
Yep.
we use just our hand, there's less mass, which means there's less force.
If we used a hammer, a steel hammer against a steel drawbar,
That's going to cause...
both the hammer and the drawbar would be getting distorted. When we hit the drawbar with something that's softer than the drawbar is, the distortion is on the block and not the drawbar,
which is a good thing.
which is a good thing. Okay, let's put the drill chuck back in.
I'm going to take this chuck, put that back in,
Yep.
the other way away.
Gonna rotate this till the key lines up. There it goes. Tighten the drawbar. Okay, tighten me up.
There we go.
Now, come on in here, Shay, and let me show a couple other things. You see in here, we got these two little pieces. There's one here, there's one against the other jaw. Those are parallels. They're called that because these surfaces are milled exactly parallel to each other. By putting those in there, we can put our work in and have it be up near the top of the vise where we can see it instead of buried down all the way inside. And then we can drill a hole through the top and the bottom without drilling into the vise. Now we've got a burr here that I'm going to have to take off. So why don't you go over and sand that off?
So we're going to take our part, take the end that needs to be sanded, flip this up. This is our sanding belt, the other side's our grinding belt. We're going to slowly push our drag us up while the end is now smooth. We're going to do this on the other side. Now that we've done that, we have not snapped our hands, which is always a good thing, but also if we can see here, clean edges. This is what we want. And now we're going to return this to the end mill.
Now, we want to be exactly in the center of this piece. How do we measure the exact center? On the vise, the measurements are in 2 dimensions. The X dimension is along the vise. The Y dimension is at right angles to the table. Okay? So we're going to set it up so we've got coordinates X and Y measured from this corner. This corner becomes 0x, 0y. That's 0, 0. Here's how we do that. You remember how to use this thing?
Yep.
Okay. Now let me point out, on the drill chuck, righty-tighty, lefty-loosey. To tighten it up, you hold this part with one hand and you twist it with the other. That's all the tightening it needs. You don't need a chuck key, you don't need anything else, just use your hands. Okay, Connor, zero us in the X dimension on this face.
So what we notice here is that this is now offset. We want to make sure when this is set about like that, we have zeroed everything. We're gonna turn the machine on.
See how that's wiggling? Okay.
We're gonna bring this closer. Yep, we're gonna lower that. And bring this closer. Oop. Come in this way.
Now, watch this. Watch this real close. See it just stopped? And you see up here how it just jumped over to the side? Do it again, Colin. Now as he moves in, and it just touches, and the instant where it jumps, that's where it makes contact. There. That's the point when the edge finder just made contact with the vise. So, I come over here to the digital readout. This is just electronic format for what you see on the dials. Okay? I do X, 0.1, enter. So I've set my X at 0.1. Why did I set it at 0.1? This end of the edge finder is 200 thousandths of an inch wide. So the center line of the edge finder is 100 thousandths from the part that touched. Right? I should have said X minus 0.1. I'm on the negative side. Now, if I move over till the digital readout reads 0, okay, that's 1.4 thousandths. It's not 14 thousandths, that's 1.4 thousandths. So now that edge finder is right on the center line within 1.4 thousandths. Now we do the same thing on the y-axis on this face. Go ahead.
All right, so we're gonna move this so that we can get the edge finder to the inside. We're gonna bring this down, and then we're gonna pull in. So there we are.
Y 0.1 minus enter. So now we set the Y at minus 0.1.
I'm gonna bring that up and make that read 0. Wrong direction.
Good.
Shut off.
Now we've got X and Y both zeroed, and we're dead on the corner of the vise. Now we can take all our dimensions as measured from this face on the Y and this face on the X. So Connor, take the edge finder out.
All right. There we go. Out comes the edge finder.
Now, Shay, come back on in here a second. Again, everybody knows what a drill bit looks like, probably, okay? Now, a drill bit is meant for drilling a hole, but you see how long and thin it is. That drill bit is prone to running off center. If you want to have a hole in an exact location, you start with a center drill like this. This is short and fat, so it stays true to the center, and this will allow you to start your hole in the exact location you want. Once you got the hole started, the drill bit will follow it, okay? So Connor, go ahead and put the work in the vise.
All right.
Square us with the end. Now I'll tighten it up. See how we did that? We used the straight edge to make the work exactly even with the end of the vise, so we know this face is exactly even with our 0 point over here. So we've got that all set. We already know the side is even with our 0 point on the y-axis, so that's all set. Connor, we want to have a Y measurement of 1 inch. We're going to be on the center line. It's a 2-inch piece.
Y.
So set the Y at -1. Perfect. Now, the first hole 1/2 inch in, so set the X at +50 500. There you go. So now you're on y minus 1, x 0.5. Give me a hole.
All right. So we're on our X and Y. The machine's spinning. We're now going to go down. And go in.
Yeah, keep going. Give me a good. That's good. Perfect.
Come out.
Now, give me 1.5 on the X.
1.5, you got it. There
Good.
we go.
Remember, our tolerance is 2/1000ths. You're at 1. You're off by 1.4. That's less than 2. You're good. Don't waste a bunch of time going back and forth trying to get it all zeros, because that's just a waste of time.
It's a bit big.
Yeah, you're a little over on that one. Okay, let's drill our holes.
All right. Stop that. Fall in. All right, oop. There we go.
All right. Okay, come on in here and let's talk about this. Now, Connor went a little too deep with that center drill. Now we got a hole that's too big. Guess what? Everybody makes mistakes. Don't get mental about it. Just move on. Try not to do it again. That's all.
Saving weight on the robot.
Oh, that's right. It's
We
a
have a
weight
weight limit.
reduction procedure. Of course.
Hey,
All right, let's drill the first hole, Connor.
that's not a problem. 500. That's 50.
You're off by 5,000.
Yeah, almost.
Good.
There we go.
Very good.
Let's go. So why not change? We moved our X back to where it was. And we're through.
Okay. Good.
Power that off.
And you can see, if you look in the end, you can see if we drill all the way through and out the bottom side of this tubing, we can still drill and not come close to hitting the vise. Okay, you just gotta have a little judgment when you break through the bottom side, not to go so far that you end up hitting the vise, which is way underneath. What did we learn? On the Bridgeport milling machine, you can cut sideways with the end mill. That also means you could go into the middle of the piece and cut a slot. You can drill holes. You can locate all your work accurately within 1/1000th of an inch without much problem at all. And that's just the beginning of what this machine can do. If you look over here, the head will tilt so you can drill at an angle. That's tilting this way. The head will also tilt this way so you can drill at a compound angle. The head will rotate around so you can reach big things. My dad used to say a Bridgeport could reach around and drill a hole in its own butt. Well, I'm not sure that's true, but it was what he used to say. It's a very versatile machine. We got a whole bunch of other handles up here that I can show you when the time comes, but for right now, that's going to be an introduction to the milling machine. Now, our other one over there is not a Bridgeport per se. It's a made in Taiwan copy, and it's a newer machine. Doesn't work any better. It's a good machine, but this old one still does the job, and it'll be doing the job long after we're gone. As with everything else, anything else you want to see, just say so. We will show you everything that's going on in here if you want to see it. That's all I've got. We'll catch you on the flip side.